Saturn, the ringed jewel of our solar system, has captivated humanity for centuries. But what if I told you that this distant planet holds secrets that could reshape the future of technology, exploration, and even life as we know it? Picture this: a world where Saturn's swirling storms power entire civilizations, where its icy moons become thriving colonies, and where its iconic rings serve as a cosmic playground for adventurers. This isn't science fiction, it's a glimpse into the possibilities that lie ahead. In this video, we'll take you on a journey through 25 bold predictions about Saturn, blending cutting-edge science with visionary imagination. From harnessing its immense energy reserves to transforming its moons into habitable worlds, we'll explore how Saturn could become a cornerstone of humanity's future. Whether you're a space enthusiast, a tech lover, or simply curious about what lies beyond our planet, this video promises to spark your imagination and leave you wondering, could Saturn be the key to unlocking the next chapter of human progress? Stay with us as we dive into these fascinating predictions, and by the end, you'll see Saturn in a whole new light. Let's begin. Now, let's turn our attention to one of the most exciting possibilities for Saturn's future, its potential as a colossal energy source. Imagine tapping into the planet's vast reserves of hydrogen, a resource so abundant that it could power entire civilizations for centuries. Saturn's atmosphere is composed primarily of hydrogen, making it a treasure trove of clean energy waiting to be harnessed. But how could we make this a reality? The first step would involve developing advanced technology capable of extracting and transporting hydrogen from Saturn's atmosphere back to Earth or other colonies. This would require spacecraft equipped with specialized collection systems, as well as innovative methods for storing and transporting hydrogen safely across vast distances. Once we overcome these challenges, the implications could be transformative. Hydrogen is a clean burning fuel, producing only water as a byproduct when used in fuel cells. This means that Saturn's hydrogen reserves could provide a sustainable energy solution, reducing our reliance on fossil fuels and helping to combat climate change. Beyond Earth, this energy source could also power future space missions, enabling us to explore deeper into the solar system and beyond. Picture a future where Saturn's hydrogen fuels interstellar travel, allowing humanity to reach distant stars and establish new colonies. The technological breakthroughs needed to achieve this are immense, but the rewards could be equally groundbreaking. By unlocking Saturn's energy potential, we could take a giant leap toward a cleaner, more sustainable future for all. And as we continue to push the boundaries of innovation, Saturn may very well become the cornerstone of humanity's energy revolution. Now, let's shift our gaze to another thrilling possibility: the colonization of Saturn's moons. Among the planet's many satellites, Titan and Enceladus stand out as prime candidates for future human settlements. Titan, Saturn's largest moon, is a world of fascinating extremes. Its thick atmosphere, rich in nitrogen, and the presence of liquid methane lakes make it a unique environment unlike anything we've encountered. Enceladus, on the other hand, is a smaller but equally intriguing moon, known for its icy surface and the geysers of water vapor that erupt from its south pole, hinting at a subsurface ocean. These features make both moons compelling targets for colonization, but the challenges are immense. Titan's surface temperatures hover around -180 degrees Celsius, requiring advanced thermal protection for any human habitats. Enceladus, while potentially harboring liquid water beneath its icy crust, is bombarded by intense radiation from Saturn's magnetic field, posing significant risks to human health. To overcome these obstacles, we would need to develop self-sustaining habitats capable of shielding inhabitants from extreme cold and radiation, while providing reliable sources of food, water, and energy. One promising approach is the use of underground structures, which could offer natural protection from radiation and temperature fluctuations. Additionally, the potential for in-situ resource utilization, such as extracting water from Enceladus's subsurface ocean or using Titan's methane as fuel, could reduce the need for constant resupply missions from Earth. If successful, these colonies could serve as stepping stones for further exploration of the outer solar system, offering a base for scientific research and even the possibility of discovering extraterrestrial life. The dream of living on Saturn's moons may seem distant, but with continued innovation and determination, it could one day become a reality, opening up a new chapter in humanity's journey among the stars. Now, let's take a leap into a future where Saturn's breathtaking rings aren't just a marvel to observe from afar, but a destination to experience up close. Picture this: floating hotels nestled within the rings, offering panoramic views of the planet's swirling storms and the shimmering bands of ice and rock that stretch for thousands of kilometers. To make this vision a reality, we'd need to overcome some extraordinary engineering challenges. First, constructing habitats that can withstand the harsh conditions of space, including micrometeoroid impacts and extreme temperatures, would be essential. These structures would need to be equipped with advanced life support systems, ensuring a safe and comfortable environment for visitors. But the real magic lies in the experiences these space tourists would enjoy. Imagine stepping out onto a viewing platform where you can gaze at the rings from just a few kilometers away, watching sunlight dance off the icy particles. Or perhaps taking a guided tour in a specially designed spacecraft, weaving through the gaps in the rings, offering a once-in-a-lifetime perspective of this cosmic wonder. For the more adventurous, there could even be opportunities for low-gravity excursions, allowing visitors to float among the ring particles, feeling like they're part of the celestial dance. Of course, the journey to Saturn itself would be an adventure. Advanced propulsion systems, possibly powered by nuclear or ion engines, would be required to reduce travel time and make the trip feasible for tourists. Once there, the infrastructure would need to include docking stations, energy sources, and even recreational facilities to ensure a memorable stay. While this may sound like science fiction, the rapid advancements in space technology suggest that such a future might not be as far off as we think. Saturn's rings, once a distant dream, could one day become the ultimate destination for those seeking to explore the wonders of our solar system. Now, let's shift our focus to a future where Saturn's rings aren't just a tourist attraction, but a treasure trove of resources waiting to be tapped. Imagine the potential of mining these iconic rings for valuable minerals and ice, unlocking a new frontier in space resource extraction. The rings, composed of countless particles of ice, rock, and dust, could hold the key to sustaining future space missions and even supporting life beyond Earth. But how would we go about such an ambitious endeavor? First, we'd need advanced robotic systems capable of navigating the delicate structure of the rings. These machines would have to be equipped with precision tools to collect and process materials without disrupting the ring system's natural balance. The ice, for instance, could be harvested and converted into water, oxygen, or even rocket fuel, providing essential resources for deep space exploration. Meanwhile, the rocky particles might contain rare minerals or metals that could be used in construction or manufacturing, both in space and back on Earth. The economic implications of such operations are staggering. Establishing a mining industry around Saturn could create a new space economy, with companies competing to extract and transport these resources. This could lead to innovations in space logistics, such as specialized cargo ships designed to ferry materials between Saturn and other destinations in the solar system. The revenue generated from these activities could fund further exploration and technological advancements, creating a self-sustaining cycle of discovery and development. Of course, the challenges are immense. The technology required to mine Saturn's rings would need to be highly durable, capable of withstanding the harsh conditions of space, including radiation and micrometeoroid impact. Additionally, ethical considerations would come into play, as we'd need to ensure that our activities don't harm the ring system or disrupt its natural beauty. Balancing resource extraction with preservation will be crucial as we venture into this new era of space industry. As we look ahead, the idea of mining Saturn's rings opens up a world of possibilities. It's not just about the resources themselves, but about the potential to revolutionize how we think about space exploration and sustainability. With the right technology and careful planning, Saturn's rings could become a cornerstone of humanity's future in the cosmos. And as we continue to push the boundaries of what's possible, who knows what other secrets these shimmering bands of ice and rock might hold? Now, let's turn our gaze to the stars and explore how Saturn could become a cosmic observatory unlike anything we've ever seen. Picture this: advanced telescopes stationed on Saturn or its moons, peering into the depths of the universe with unparalleled clarity. Saturn's unique position in the solar system offers a vantage point that could revolutionize our understanding of distant galaxies, black holes, and the very fabric of space-time. One of the key advantages of placing telescopes on Saturn is its distance from the Sun. Unlike Earth-based observatories, which are often hindered by atmospheric interference and light pollution, Saturn's telescopes would operate in the cold, dark expanse of space, free from these limitations. This would allow for sharper, more detailed images of celestial objects, revealing secrets of the cosmos that have remained hidden until now. Imagine capturing the birth of stars in distant nebulae or observing the collision of galaxies billions of light years away with unprecedented precision. Saturn's moons, particularly Titan and Enceladus, could serve as ideal locations for these observatories. Titan's thick atmosphere could shield telescopes from solar radiation, while Enceladus's icy surface might provide a stable platform for long-term observations. These moons could host arrays of telescopes working in unison, creating a network capable of capturing data from multiple angles and wavelengths. This collaborative approach would deepen our understanding of cosmic phenomena, from the behavior of dark matter to the origins of the universe itself. But why stop at visible light? Saturn's observatories could also be equipped to detect other forms of radiation, such as radio waves, X-rays, and gamma rays. This multi-spectrum approach would allow scientists to study the universe in ways that are currently impossible, uncovering new insights into the nature of black holes, neutron stars, and other enigmatic objects. The data gathered could answer fundamental questions about the universe's composition, expansion, and ultimate fate. Of course, building and maintaining such observatories would require groundbreaking technology and international collaboration. We'd need advanced robotics to construct and repair these instruments in the harsh environment of space, as well as innovative communication systems to transmit vast amounts of data back to Earth. The challenges are significant, but the potential rewards are even greater. By turning Saturn into a cosmic observatory, we could unlock mysteries that have puzzled humanity for centuries. As we look to the future, Saturn's role as a window to the universe becomes increasingly compelling. It's not just about observing the stars, but about expanding our understanding of where we come from and where we might be headed. With Saturn as our cosmic observatory, the possibilities are as vast as the universe itself. And who knows, the discoveries made there could redefine our place in the cosmos, inspiring generations to come. Now, let's shift our focus to one of Saturn's most intriguing moons, Titan, and imagine a future where humanity transforms this icy world into a habitable paradise. Terraforming Titan is a concept that blends science fiction with cutting-edge science, and while it may sound like a distant dream, the steps to make it a reality are grounded in real-world possibilities. The first challenge in terraforming Titan is addressing its extreme cold. With surface temperatures averaging around -180 degrees Celsius, Titan is far too frigid for life as we know it. To warm the moon, scientists propose using massive mirrors or orbital reflectors to redirect sunlight onto its surface. Another idea involves releasing greenhouse gases, such as methane or carbon dioxide, into Titan's atmosphere to trap heat and gradually raise temperatures. Over time, these methods could create a more temperate environment, melting Titan's vast reserves of ice and potentially forming liquid water, a key ingredient for life. But warming Titan is only the first step. The Moon's atmosphere, while thick, is composed mostly of nitrogen with traces of methane, making it unbreathable for humans. To create a breathable atmosphere, we'd need to introduce oxygen through processes like photosynthesis. This could involve seeding Titan with genetically engineered plants or algae capable of surviving in its unique conditions. These organisms would convert carbon dioxide into oxygen, slowly transforming the atmosphere into one that could support human life. Alternatively, advanced technology might allow us to artificially produce oxygen on a large scale, though this would require immense energy and resources. Of course, terraforming Titan isn't just a technical challenge, it's also an ethical one. Should we alter an entire world, even if it's currently uninhabitable? Titan's unique environment, with its methane lakes and complex organic chemistry, could hold clues to the origins of life in our solar system. By terraforming the Moon, we risk destroying these scientific treasures before we fully understand them. There's also the question of whether we have the right to reshape another world for our own benefit, especially when we're still grappling with the environmental consequences of our actions on Earth. Despite these challenges, the idea of terraforming Titan remains a tantalizing possibility. It represents humanity's drive to explore, adapt, and thrive in even the most hostile environments. If successful, Titan could become a second home for our species, a place where we can test the limits of our ingenuity and resilience, and who knows? The lessons we learn from terraforming Titan could one day help us transform other worlds, expanding our reach across the cosmos. As we ponder the future of Titan, it's clear that this moon holds immense potential, not just as a scientific curiosity, but as a testament to what humanity can achieve when we dare to dream big. The journey to terraform Titan may be long and fraught with challenges, but the rewards could be nothing short of extraordinary. Now, let's take a leap beyond Saturn's moons and explore how this majestic planet could play a pivotal role in humanity's journey to the stars. Imagine Saturn not just as a destination, but as a cosmic launchpad for interstellar travel. This idea revolves around a concept known as gravity assist, or the slingshot effect, where a spacecraft uses a planet's gravity to gain speed and alter its trajectory without expending additional fuel. Saturn, with its immense gravitational pull, could be the perfect candidate for such a maneuver. The slingshot effect works by sending a spacecraft close to a planet, where it gets a gravitational boost as it swings around. This technique has already been used in missions like Voyager and Cassini, but Saturn's size and position in the solar system make it uniquely suited for interstellar missions. By using Saturn's gravity, spacecraft could achieve the incredible speeds needed to venture beyond our solar system and into the vast expanse of interstellar space. This could drastically reduce travel time to nearby star systems, making the dream of exploring other worlds a tangible reality. One of the most exciting possibilities is using Saturn as a stepping stone for missions to Proxima Centauri, the closest star system to our own. With current technology, such a journey would take tens of thousands of years, but a well-timed gravity assist from Saturn could cut that time significantly. By harnessing the planet's gravitational energy, we could propel spacecraft to velocities that were once thought impossible, opening the door to interstellar exploration within a human lifetime. Of course, this isn't without its challenges. Navigating a spacecraft through Saturn's complex gravitational field requires precise calculations and advanced technology. Even the slightest miscalculation could send a mission off course, potentially stranding it in the void of space. Additionally, the intense radiation around Saturn poses risks to both the spacecraft and any potential crew, requiring robust shielding and innovative solutions to ensure safety. Despite these hurdles, the potential rewards are immense. Saturn's role in interstellar travel could mark a turning point in our exploration of the cosmos. It's not just about reaching new destinations, it's about pushing the boundaries of what's possible and redefining our place in the universe. As we look to the stars, Saturn stands as a symbol of humanity's ingenuity and determination, a celestial ally in our quest to explore the unknown. With Saturn as our cosmic slingshot, the dream of interstellar travel becomes more than just science fiction. It becomes a tangible goal, one that could reshape our understanding of the universe and our place within it. The journey may be long, but with Saturn's gravity on our side, the stars are closer than we think. Now, let's shift our gaze from Saturn's natural wonders to a bold and imaginative idea. What if we could create artificial rings around this majestic planet? Picture this: Saturn, already adorned with its iconic rings, now enhanced by human ingenuity, becoming a canvas for both scientific discovery and breathtaking beauty. This concept might sound like science fiction, but with advancements in technology, it could one day become a reality. Creating artificial rings around Saturn would require a combination of cutting-edge materials and innovative engineering. The first challenge would be sourcing the materials. Unlike Saturn's natural rings, which are made up of ice, rock, and dust, artificial rings would likely need to be constructed from lightweight, durable materials capable of withstanding the harsh conditions of space. Think of advanced alloys, carbon-based composites, or even nanomaterials designed to endure extreme temperatures and radiation. Once the materials are secured, the next step would be deploying them into orbit around Saturn. This could involve launching massive construction platforms or robotic assemblers capable of building the rings piece by piece. These platforms would need to be equipped with precision tools to ensure the rings are stable and evenly distributed. The process would be a monumental feat of engineering, requiring careful coordination and meticulous planning to avoid collisions with Saturn's existing rings or moons. But why go through all this effort? The scientific benefits could be immense. Artificial rings could serve as massive observatories, capturing data about Saturn's atmosphere, magnetic field, and gravitational interactions. They could also act as shields, protecting future colonies or spacecraft from harmful radiation. On the aesthetic side, imagine the cultural impact of a human-made celestial marvel visible from Earth. These rings could become a symbol of humanity's creativity and ambition, inspiring generations to dream bigger and reach further. Of course, such a project wouldn't be without its challenges. The cost alone would be astronomical, requiring global collaboration and long-term investment. There's also the ethical question of altering a natural wonder of the solar system. Should we preserve Saturn's rings as they are, or is it our destiny to leave our mark on the cosmos? These are questions that would need careful consideration as we move forward. As we ponder the possibilities, one thing is clear: the idea of artificial rings around Saturn pushes the boundaries of what we believe is possible. It's a testament to human curiosity and our desire to shape the universe around us. Whether for science, art, or both, this vision of Saturn's future reminds us that the stars are not just places to visit, they're places to transform. And with each bold idea, we take one step closer to making the extraordinary a reality. Next, let's turn our attention to another fascinating concept. What if Saturn's rings could become a cosmic art gallery, visible not just from space but from Earth itself? Stay tuned as we explore how humanity's creativity could reach new heights among the stars. Now, let's take a step into the realm of imagination and creativity. What if Saturn's rings could become a cosmic art gallery, a place where humanity's artistic vision meets the vastness of space? Picture this: Saturn, already a breathtaking sight, transformed into a celestial canvas where massive art installations orbit the planet, visible not just from space but even from Earth. This idea might seem like a far-off dream, but with the right blend of technology and ambition, it could one day become a reality. The concept of turning Saturn's rings into an art gallery would require groundbreaking advancements in both space engineering and artistic innovation. Imagine using reflective materials or light-based technologies to create patterns, shapes, or even moving images within the rings. These installations could be designed to change over time, creating a dynamic display that evolves with the seasons or significant cultural events. The rings themselves, made up of countless particles, could be manipulated to form intricate designs, turning Saturn into a living, breathing masterpiece. From a cultural perspective, this project could redefine how we think about art and its role in society. A cosmic art gallery would transcend borders, languages, and cultures, offering a universal experience that connects humanity in a shared moment of awe. It could inspire new forms of artistic expression, pushing creators to think beyond traditional mediums and embrace the infinite possibilities of space. Imagine artists collaborating with scientists to design installations that not only captivate the eye, but also convey messages about our place in the universe or the challenges facing our planet. Technologically, the challenges would be immense but not insurmountable. Creating art on such a grand scale would require precise control over the materials used in Saturn's rings. Advanced robotics and artificial intelligence could play a key role in shaping and maintaining these installations, ensuring they remain stable and visually stunning. The logistics of transporting materials and equipment to Saturn would also be a monumental task, requiring international cooperation and significant investment. But the payoff, a celestial art gallery visible to billions, could be worth the effort. There's also the question of accessibility. How would people on Earth experience this cosmic art? Telescopes and augmented reality technologies could bring the installations to life, allowing anyone with a smartphone or a telescope to witness the beauty of Saturn's rings in a whole new way. Schools, museums, and cultural institutions could use this as an opportunity to educate and inspire, fostering a deeper connection between humanity and the cosmos. Of course, this idea isn't without its ethical considerations. Should we alter a natural wonder like Saturn's rings for artistic purposes? Some might argue that the rings should remain untouched, a pristine example of the universe's natural beauty. Others might see this as an opportunity to leave a lasting legacy, a testament to human creativity and our ability to shape the world around us. These are questions that would need careful thought and global dialogue. As we explore this vision, one thing becomes clear: the idea of Saturn as a cosmic art gallery is more than just a flight of fancy. It's a reminder of the boundless potential of human imagination and our desire to leave a mark on the universe. Whether through science, art, or a combination of both, this concept challenges us to think bigger and dream bolder. And who knows, perhaps one day, Saturn's rings will not only be a marvel of nature but also a masterpiece of human ingenuity. Next, let's shift our focus to another intriguing possibility. What if Saturn's powerful storms could be harnessed as a source of energy? Stay tuned as we dive into the potential of tapping into the planet's extreme weather phenomena. Now, let's turn our attention to a concept that combines raw power with futuristic innovation. What if Saturn's colossal storms could be harnessed as a source of energy? Saturn is home to some of the most extreme weather phenomena in our solar system, with winds reaching speeds of over 1,000 miles per hour and storms that can last for decades. Imagine capturing even a fraction of that energy and using it to power human colonies, spacecraft, or even entire planets. This idea might sound like science fiction, but with the right technology, it could become a groundbreaking reality. The first challenge lies in understanding the sheer scale of Saturn's storms. The planet's most famous storm, the Great White Spot, is a massive weather system that can span thousands of miles. These storms are fueled by the planet's internal heat and rapid rotation, creating a chaotic and dynamic atmosphere. To harness this energy, we would need to develop technologies capable of withstanding these extreme conditions. Think of advanced materials and structures that can endure high-speed winds, intense pressure, and freezing temperatures. It's a tall order, but not impossible with the right advancements in engineering. One potential approach could involve deploying energy-capturing devices directly into Saturn's atmosphere. These devices, perhaps resembling high-tech kites or drones, could be designed to float within the storm systems, converting the kinetic energy of the wind into electricity. The energy could then be transmitted back to orbiting stations or even to nearby moons like Titan, where it could support human settlements or scientific missions. This would require breakthroughs in wireless energy transmission and long-distance power storage, but the payoff could be immense. Another possibility is to use Saturn's storms as a natural laboratory for studying energy generation in extreme environments. By observing how these storms form and sustain themselves, scientists could gain insights into more efficient ways to capture and store energy. This knowledge could have applications far beyond Saturn, potentially revolutionizing how we generate power on Earth or other planets. For example, understanding the dynamics of Saturn's storms could lead to the development of more robust wind turbines or new methods of energy extraction from turbulent environments. Of course, there are significant challenges to consider. The logistics of deploying and maintaining equipment in such a hostile environment would be daunting. Saturn's storms are not only powerful but also unpredictable, making it difficult to ensure the safety and stability of any energy-capturing devices. Additionally, the cost of such a project would be astronomical, requiring international collaboration and substantial investment. However, the potential benefits access to a nearly limitless source of clean energy could make it a worthwhile endeavor. From an environmental perspective, harnessing Saturn's storms could offer a sustainable alternative to traditional energy sources. Unlike fossil fuels, which contribute to climate change, this method would rely on natural planetary processes, leaving no harmful byproducts. It could also reduce our reliance on Earth's finite resources, paving the way for a more sustainable future both on our planet and beyond. As we explore this idea, it's clear that Saturn's storms represent not just a scientific curiosity, but a potential game-changer for energy production. The challenges are significant, but so are the possibilities. By pushing the boundaries of what's possible, we could unlock a new era of energy innovation, one that draws inspiration from the very forces that shape our universe. Next, let's consider another fascinating aspect of Saturn's influence. What if its gravitational pull could one day affect Earth's climate? Stay tuned as we delve into the science behind this intriguing possibility. Now, let's shift our gaze to a concept that might sound like it's straight out of a cosmic thriller. What if Saturn's gravitational pull could one day influence Earth's climate? While it may seem far-fetched at first, the gravitational forces of planets in our solar system do interact in subtle yet significant ways. Saturn, with its immense size and distance, exerts a gravitational influence that, under certain conditions, could potentially ripple across the solar system and affect Earth's climate patterns. To understand how this might work, we need to look at the science of gravitational interactions. Planets don't just orbit the Sun in isolation. They tug on each other through gravity, creating a delicate dance of forces. These interactions can lead to phenomena like orbital resonances, where the gravitational pull of one planet affects the orbit of another over long periods of time. For example, Saturn's gravity has a known influence on Jupiter's orbit, which in turn can affect the entire solar system's dynamics. Over millions of years, these subtle shifts could theoretically alter Earth's orbit or axial tilt, leading to changes in our climate. One of the most intriguing possibilities is the idea of Milankovitch cycles, long-term variations in Earth's orbit and tilt that are influenced by the gravitational pull of other planets, including Saturn. These cycles are already known to play a role in Earth's ice ages and warming periods. If Saturn's gravitational influence were to amplify or alter these cycles, it could lead to significant shifts in Earth's climate. For instance, a slight change in Earth's axial tilt could result in more extreme seasons or prolonged periods of glaciation. Another angle to consider is the potential for Saturn's gravity to affect the stability of Earth's atmosphere. While this is more speculative, some scientists have theorized that gravitational interactions could influence the distribution of atmospheric gases or even the intensity of solar radiation reaching Earth. This could have cascading effects on weather patterns, ocean currents, and global temperatures. Imagine a scenario where Saturn's gravitational pull subtly alters the jet stream, leading to more frequent and intense storms or droughts on Earth. Of course, the timescales involved in these processes are immense. Any noticeable impact from Saturn's gravity would likely take millions of years to manifest. However, studying these interactions could provide valuable insights into the long-term stability of Earth's climate and help us better understand the forces that shape our planet's environment. It also raises fascinating questions about the interconnectedness of our solar system and how even distant planets can play a role in Earth's future. From a practical standpoint, this idea underscores the importance of monitoring and modeling gravitational interactions within our solar system. By improving our understanding of these dynamics, we could potentially predict and prepare for long-term climate changes, whether they're influenced by Saturn or other celestial bodies. It's a reminder that Earth doesn't exist in isolation. It's part of a larger cosmic system where even the smallest gravitational nudge can have far-reaching consequences. As we ponder this possibility, it's clear that Saturn's influence extends far beyond its iconic rings and storms. Its gravitational pull, though subtle, could one day play a role in shaping Earth's climate, reminding us of the intricate connections that bind our solar system together. Next, let's explore another captivating idea. What if Saturn's rings could serve as a cosmic time capsule, preserving information for future civilizations? Stay tuned as we uncover the potential of this extraordinary concept. Now, let's turn our attention to a concept that feels like it's been plucked from the pages of science fiction. What if Saturn's rings could serve as a cosmic time capsule, preserving information for future civilizations? This idea might sound fantastical, but when we consider the unique properties of Saturn's rings, it starts to feel surprisingly plausible. Imagine a vast, shimmering archive floating in space, holding the collective knowledge of humanity for generations to come. But how could we make this a reality? First, let's think about the environment of Saturn's rings. They're composed of countless particles of ice and rock, ranging in size from tiny grains to massive boulders. This dynamic and ever-changing structure might seem like an unlikely place to store data, but it's precisely this complexity that could make it ideal. The rings are relatively stable over long periods, protected by Saturn's immense gravity and magnetic field. This stability could provide a safe haven for encoded information, shielding it from the harsh conditions of space. The next question is, how would we encode and preserve data in such an environment? One possibility is to use advanced nanotechnology to embed information directly into the ice particles. Imagine tiny, durable capsules, each containing vast amounts of data scattered throughout the rings. These capsules could be designed to withstand extreme temperatures, radiation, and micrometeorite impacts, ensuring the information remains intact for millennia. Alternatively, we could use laser technology to etch data onto the surfaces of larger ice chunks, creating a kind of cosmic library that future civilizations could decode. But encoding the data is only half the challenge. We'd also need a way to ensure that future explorers, whether human or extraterrestrial, could access and interpret it. This would require creating a universal language or system of symbols that transcends time and culture. Think of it like the Rosetta Stone, but on a cosmic scale. By embedding instructions alongside the data, we could guide future civilizations in decoding the information, ensuring that our knowledge isn't lost to the ages. Of course, the technology needed to achieve this is still in its infancy. We'd need breakthroughs in materials science, data storage, and space engineering to make this vision a reality. But the potential rewards are immense. By storing information in Saturn's rings, we could create a lasting legacy that outlives our civilization, preserving our achievements, discoveries, and even our stories for future generations to uncover. It's a way of reaching across time, connecting with those who might one day look to the stars and wonder about the beings who came before them. As we explore this idea, it's worth considering the ethical implications as well. What kind of information should we preserve? Who decides what gets included in this cosmic archive? These are questions that would require careful thought and collaboration, ensuring that the time capsule reflects the best of humanity while leaving room for future civilizations to interpret it in their own way. The concept of Saturn's rings as a cosmic time capsule is both inspiring and humbling. It reminds us of our place in the universe and the potential for our knowledge to endure long after we're gone. Next, let's dive into another fascinating possibility. What if Saturn's moons could serve as biological laboratories, offering us a chance to study extraterrestrial life? Stay tuned as we explore this thrilling frontier. Now, let's shift our gaze to another extraordinary possibility. What if Saturn's moons could serve as biological laboratories, offering us a unique opportunity to study extraterrestrial life? This idea isn't as far-fetched as it might seem. Saturn's moons, particularly Titan and Enceladus, have long fascinated scientists due to their potential to harbor life. These celestial bodies are more than just rocky or icy worlds. They could be the key to unlocking some of the universe's greatest mysteries. Titan, Saturn's largest moon, is a world of lakes and rivers, but not of water. Instead, it's filled with liquid methane and ethane, creating an environment unlike anything on Earth. This moon's thick atmosphere and complex chemistry make it a prime candidate for studying how life might develop under radically different conditions. Imagine sending robotic explorers to Titan, equipped with advanced sensors to analyze its lakes and soil. What if we discovered microbial life thriving in these methane-rich environments? Such a discovery would revolutionize our understanding of biology, proving that life can exist in forms and places we've never imagined. Then there's Enceladus, a smaller but equally intriguing moon. Beneath its icy surface lies a vast ocean, warmed by hydrothermal vents similar to those found in Earth's deep seas. These vents could provide the energy and nutrients needed to support life, making Enceladus one of the most promising places to search for extraterrestrial organisms. Imagine drilling through the ice and sending submersibles into its hidden ocean. What kind of life might we find there? Even the discovery of simple microbes would be a monumental breakthrough, offering clues about how life begins and evolves in the cosmos. But the potential for scientific discovery doesn't stop there. Studying life on Saturn's moons could also help us understand the origins of life on Earth. By comparing extraterrestrial organisms to those on our planet, we could uncover universal principles of biology, what makes life possible, and how it adapts to different environments. This research could even lead to advancements in medicine, agriculture, and biotechnology, as we learn from the unique adaptations of alien life forms. Of course, the challenges are immense. The extreme cold, radiation, and distance from Earth make these missions incredibly difficult. We'd need cutting-edge technology to survive and operate in such harsh conditions. But the rewards could be unparalleled. Discovering life beyond Earth would not only answer one of humanity's oldest questions, are we alone in the universe, but also inspire a new era of exploration and innovation. As we ponder the possibilities, it's worth considering the ethical implications as well. How should we approach the study of extraterrestrial life? what responsibilities do we have to protect these potential ecosystems? These are questions that will require careful thought and international collaboration, ensuring that our quest for knowledge doesn't come at the cost of harming other worlds. The idea of Saturn's moons as biological laboratories is both thrilling and profound. It challenges us to think beyond our own planet and imagine a future where we're not just explorers of space, but students of the universe. Next, let's turn our attention to another captivating concept. What if Saturn's unique environment could become a playground for extreme sports and recreational activities? Stay tuned as we dive into this exciting vision. Now, let's take a leap into the realm of imagination and consider Saturn not just as a scientific wonder, but as a cosmic playground. Picture this: Saturn's breathtaking rings, its swirling storms, and its low-gravity moons transformed into arenas for extreme sports and recreational activities. This vision might sound like science fiction, but with the right technology and innovation, it could become a reality. Imagine skydiving through Saturn's upper atmosphere, where the winds whip at incredible speeds and the sky glows with hues of gold and orange. The thrill of free falling through such a dynamic environment would be unlike anything experienced on Earth. Or consider the possibility of ice surfing on Enceladus, gliding across its frozen surface with Saturn's rings as your backdrop. The low gravity would allow for jumps and maneuvers that defy Earth's limitations, creating a whole new category of extreme sports. Even Saturn's rings could become a destination for adventure. Picture floating platforms or tethered habitats where visitors could experience the sensation of walking or bouncing on the icy particles that make up the rings. The sheer beauty of being surrounded by these shimmering structures would make it a once-in-a-lifetime experience. And for those seeking a more relaxed activity, imagine stargazing from Titan, where Saturn's massive presence dominates the sky, offering a view that's both awe-inspiring and serene. Of course, turning Saturn into a cosmic playground comes with significant challenges. Safety would be a top priority, as the planet's extreme weather, radiation, and distance from Earth pose serious risks. Advanced protective gear, reliable transportation systems, and fail-safe emergency protocols would be essential to ensure the well-being of participants. Additionally, the environmental impact of such activities would need careful consideration to preserve Saturn's natural beauty and scientific value, but the potential rewards are immense. Beyond the thrill and excitement, these activities could inspire a new generation of explorers and adventurers, fostering a deeper connection between humanity and the cosmos. They could also drive technological advancements, pushing the boundaries of what's possible in space travel and habitation. As we dream of Saturn as a cosmic playground, it's worth reflecting on how such experiences could reshape our perspective on the universe. They remind us that space isn't just a place for discovery, it's a place for wonder, creativity, and human expression. Next, let's explore another fascinating idea. What if Saturn's rings could serve as a cosmic calendar, marking time on a scale beyond our imagination? Stay tuned as we unravel this intriguing concept. Now, let's shift our gaze to a concept that blends the practical with the poetic: Saturn's rings as a cosmic calendar. Imagine a system where the intricate patterns and movements of Saturn's rings could serve as a way to measure time on a scale far beyond our earthly clocks. This idea isn't just about marking days or years. It's about creating a universal timeline that could be understood across civilizations, both human and potentially extraterrestrial. Saturn's rings are in constant motion, with each ring orbiting the planet at different speeds. By tracking these movements, we could develop a method to mark time over vast periods. For example, the slow drift of the outermost ring could represent centuries, while the faster-moving inner rings could track shorter intervals like years or even months. This system could be invaluable for long-term space missions, where traditional calendars might lose relevance over decades or centuries of travel. astronauts or future spacefarers could use Saturn's rings as a reference point, aligning their missions with the cosmic rhythms of the solar system. But the applications don't stop there. A cosmic calendar based on Saturn's rings could also serve as a historical record, preserving events on a universal scale. Imagine encoding significant milestones like the first human landing on Mars or the discovery of life on another moon into the movements of the rings. Future generations or even other civilizations could look to Saturn and decode the history of our achievements and discoveries. It's a way to leave a lasting legacy, etched not in stone but in the very fabric of space. Of course, creating such a system would require advanced technology and a deep understanding of Saturn's ring dynamics. We'd need precise instruments to measure and predict the ring's movements, as well as a way to encode and decode information within them. But the potential is staggering. A cosmic calendar could unite humanity under a shared sense of time, transcending cultural and planetary boundaries. As we ponder this idea, it's worth considering how it could change our relationship with time itself. Instead of being bound by the ticking of a clock, we'd be connected to the grand, sweeping motions of the cosmos. Saturn's rings, already a symbol of beauty and mystery, could become a symbol of unity and continuity, a reminder that we are part of something much larger than ourselves. Next, let's explore another fascinating possibility. What if Saturn could serve as a cosmic recycling center, using its immense gravity to collect and repurpose space debris? Stay tuned as we dive into this innovative concept. Now, let's turn our attention to a concept that could transform Saturn into a cosmic recycling center. Picture this: Saturn's immense gravitational pull, one of the strongest in our solar system, being harnessed to collect and repurpose space debris. This idea isn't just about cleaning up the clutter in our cosmic neighborhood. It's about creating a sustainable future for space exploration and beyond. Space debris, or space junk, is a growing problem. Thousands of defunct satellites, spent rocket stages, and fragments from collisions orbit Earth, posing risks to active spacecraft and future missions. But what if we could redirect this debris towards Saturn? The planet's gravity could act as a natural vacuum, pulling in these objects and preventing them from cluttering other regions of space. Once captured, the debris could be broken down and recycled into raw materials for future missions. Imagine turning old satellites into fuel, construction materials, or even habitats for space colonies. It's a vision of sustainability that extends far beyond Earth. The environmental benefits of such a system are immense. By clearing space debris, we'd reduce the risk of collisions, which can create even more fragments and exacerbate the problem. This would make space travel safer and more efficient, protecting both human missions and valuable equipment. Additionally, recycling debris into usable materials would reduce the need to launch new resources from Earth, cutting down on costs and environmental impact. It's a win-win for both space exploration and our planet. Of course, the technological challenges are significant. We'd need advanced systems to guide debris towards Saturn without endangering active spacecraft or the planet itself. This would require precise calculations and innovative propulsion methods to ensure the debris follows a safe trajectory. Once the debris reaches Saturn, we'd need machinery capable of processing it in the harsh conditions of space. These technologies are still in their infancy, but the potential rewards make the effort worthwhile. Beyond the practical benefits, this concept could redefine our relationship with space. Instead of viewing it as a vast, untouchable void, we'd see it as a resource to be managed and preserved. Saturn, with its majestic rings and powerful gravity, could become a symbol of humanity's commitment to sustainability, a cosmic reminder that even in the vastness of space, we have a responsibility to care for our environment. As we consider this idea, it's worth reflecting on how it aligns with our broader goals for space exploration. By turning Saturn into a recycling hub, we'd not only solve a pressing problem but also pave the way for a more sustainable future in the cosmos. It's a bold vision, but one that could reshape our approach to space for generations to come. Next, let's explore another intriguing possibility. What if Saturn became a neutral meeting point for interstellar civilizations? Stay with us as we delve into the fascinating world of galactic diplomacy. Now, let's shift our gaze to a future where Saturn isn't just a planet but a cosmic crossroads, a neutral meeting ground for interstellar civilizations. Picture this: Saturn, with its awe-inspiring rings and strategic location in the solar system, serving as a hub for diplomacy among advanced species from across the galaxy. This idea isn't just science fiction. It's a vision that could redefine how civilizations interact in the vast expanse of space. The concept of Saturn as a diplomatic hub hinges on its unique position and characteristics. Located far from Earth but still within reach, Saturn offers a neutral zone where different civilizations could convene without territorial disputes or political tensions. Its rings and moons provide ample space for constructing meeting facilities, research stations, and even cultural exchange centers. Imagine a grand hall floating in orbit around Saturn, where representatives from distant star systems gather to negotiate treaties, share knowledge, and foster peace. The logistics of such a venture would be monumental but not impossible. Advanced spacecraft capable of interstellar travel would need to navigate the complexities of Saturn's gravitational field and atmospheric conditions. Infrastructure would have to be built to accommodate diverse life forms, each with their own environmental needs. Communication systems would need to bridge vast distances, ensuring real-time dialogue between civilizations. While these challenges are significant, the potential rewards peaceful coexistence, shared technological advancements, and cultural enrichment make the effort worthwhile. The significance of Saturn as a diplomatic hub extends beyond practicality. It would symbolize humanity's commitment to unity and cooperation on a cosmic scale. By choosing Saturn as a neutral meeting point, we demonstrate our willingness to engage with other civilizations as equals, fostering mutual respect and understanding. This could pave the way for collaborative efforts in exploration, resource sharing, and even joint missions to uncharted regions of the galaxy. Moreover, Saturn's role in galactic diplomacy could inspire a new era of interstellar governance. Just as Earth has organizations like the United Nations, Saturn could host a galactic council where representatives from multiple civilizations work together to address universal challenges, climate crises, resource scarcity, or even threats from rogue celestial bodies. This council could establish laws and protocols to ensure peaceful coexistence and sustainable development across the cosmos. As we contemplate this vision, it's worth considering how it aligns with our broader aspirations for space exploration. By transforming Saturn into a diplomatic hub, we'd not only solve practical challenges but also elevate our role in the galactic community. It's a bold step toward a future where humanity is not just a resident of Earth but an active participant in the interstellar dialogue. Next, let's explore another fascinating possibility. What if Saturn's atmosphere could be used to create unique soundscapes, turning the planet into a cosmic music hall? Stay with us as we uncover the artistic potential of Saturn's skies. Now, let's take a moment to imagine Saturn not just as a planet of diplomacy, but as a stage for cosmic artistry. What if Saturn's atmosphere could be transformed into a vast interstellar music hall, where the very winds and storms of the planet create symphonies unlike anything we've ever heard? This idea might sound like something out of a dream, but when we dive into the science and creativity behind it, the possibilities are as fascinating as they are profound. First, let's address the science of sound in space. On Earth, sound travels through air, vibrating molecules to create the waves we hear. But space is a vacuum, meaning there's no air to carry sound. So how could Saturn's atmosphere produce music? The answer lies in its thick, swirling gases. Saturn's atmosphere is composed mostly of hydrogen and helium, with powerful winds and storms that can reach speeds of over 1,000 miles per hour. These atmospheric conditions create vibrations that, if captured and translated, could be converted into sound. Imagine microphones or sensors designed to pick up these vibrations, transforming the howling winds and roaring storms into a symphony of natural soundscapes. The artistic possibilities here are endless. Picture a concert where the music isn't composed by humans but by the planet itself. Artists could use Saturn's atmospheric data to create unique compositions, blending the raw, untamed sounds of the planet with human creativity. These soundscapes could range from hauntingly beautiful melodies to thunderous, awe-inspiring crescendos, offering listeners a glimpse into the raw power and majesty of Saturn. It's a fusion of science and art that could redefine how we experience music, taking it beyond Earth and into the cosmos. But the concept of Saturn as a cosmic music hall goes beyond just sound. Imagine a future where these soundscapes are paired with visual displays, using Saturn's rings and swirling storms as a backdrop for immersive performances. Artists could project light shows onto the rings, creating a multisensory experience that combines sight and sound in ways that are truly out of this world. This could become a new form of interstellar entertainment, drawing audiences from across the galaxy to witness the beauty and creativity that Saturn has to offer. Of course, the challenges of creating such a music hall are significant. The technology required to capture and translate Saturn's atmospheric vibrations would need to be incredibly advanced, capable of withstanding the planet's harsh conditions. Communication systems would need to relay these sounds back to Earth or other listening stations in real time. And artists would need to collaborate closely with scientists to ensure that the music remains true to the planet's natural rhythms while still being accessible and enjoyable for audiences. Yet the rewards of such a project could be immense. By turning Saturn into a cosmic music hall, we'd not only create a new form of art but also deepen our connection to the planet. It would be a reminder that the universe is not just a place of science and exploration, but also of beauty and creativity. Saturn's music could inspire future generations, sparking a sense of wonder and curiosity about the cosmos. As we ponder this artistic vision, let's turn our attention to another intriguing possibility. What if Saturn's rings could serve as a cosmic mirror, reflecting sunlight to other planets or moons? Join us as we explore how this idea could transform the way we think about energy and terraforming in space. Now, shifting our gaze from the artistic to the practical, let's consider how Saturn's rings could serve as more than just a stunning visual feature. Imagine if these vast, icy rings could act as a cosmic mirror, reflecting sunlight to other planets or moons in our solar system. This concept might sound like science fiction, but when we break it down, the potential applications are both groundbreaking and transformative. First, let's explore how this could work. Saturn's rings are made up of countless particles of ice and rock, ranging in size from tiny grains to massive boulders. These particles are highly reflective, which is why Saturn's rings shine so brightly in the sunlight. By strategically positioning reflective materials or even enhancing the natural reflectivity of the rings, we could redirect sunlight to areas that are otherwise shrouded in darkness. For example, sunlight reflected from Saturn's rings could be directed to the surface of Titan, Saturn's largest moon, where it could help warm the surface and support future terraforming efforts. The benefits of such a project could be immense. For one, it could provide a sustainable source of energy for colonies on distant moons or planets. Instead of relying solely on solar panels or nuclear power, these colonies could harness reflected sunlight from Saturn's rings, creating a reliable and renewable energy source. Additionally, this reflected light could play a crucial role in terraforming efforts. By increasing the amount of sunlight reaching a planet or moon, we could raise surface temperatures, melt ice, and even create conditions suitable for liquid water, a key ingredient for life. But the potential doesn't stop there. Reflecting sunlight from Saturn's rings could also help distribute energy more evenly across the solar system. For instance, moons or planets with long periods of darkness, such as those in the outer reaches of our solar system, could benefit from a steady supply of reflected light. This could make these distant worlds more hospitable for exploration and habitation, opening up new frontiers for humanity. Of course, the challenges of turning Saturn's rings into a cosmic mirror are significant. The technology required to enhance or manipulate the reflectivity of the rings would need to be incredibly advanced. We'd also need to develop precise methods for directing the reflected light to specific targets, ensuring that the energy is delivered where it's needed most. And as with any large-scale project in space, the costs and logistical hurdles would be substantial, yet the rewards could far outweigh the challenges. By harnessing Saturn's rings as a cosmic mirror, we could unlock new possibilities for energy distribution, terraforming, and even the search for extraterrestrial life. It's a vision that combines innovation, ambition, and a deep respect for the natural wonders of our solar system. As we reflect on this idea, let's turn our attention to another fascinating concept. What if Saturn's gravitational field could be used as a cosmic time machine, allowing us to study the effects of time dilation? Join us as we delve into the science and possibilities behind this intriguing prediction. Now, let's take a step into the realm of theoretical physics and explore how Saturn's immense gravitational field could serve as a cosmic time machine. This idea might sound like something straight out of a science fiction novel, but it's rooted in the fascinating principles of Einstein's theory of relativity. Specifically, we're talking about time dilation, a phenomenon where time passes at different rates depending on the strength of gravity or the speed at which an object is moving. Saturn, with its massive size and strong gravitational pull, creates a unique environment where time dilation could be studied in ways that are impossible on Earth. According to Einstein's theory, time slows down in stronger gravitational fields. This means that if we were to place a clock near Saturn, it would tick slightly slower compared to a clock on Earth. While the difference might be minuscule, it's enough to provide valuable insights into how gravity and time are intertwined. One of the most exciting possibilities is using Saturn as a natural laboratory to test and refine our understanding of time dilation. By sending advanced probes or satellites into orbit around Saturn, scientists could measure the effects of its gravity on time with unprecedented precision. These experiments could help us better understand the fundamental nature of time itself and potentially uncover new aspects of how gravity shapes the universe. But the implications go even further. If we can harness the knowledge gained from studying time dilation around Saturn, it could pave the way for breakthroughs in space travel. For instance, understanding how gravity affects time could help us develop more accurate navigation systems for spacecraft traveling at high speeds or near massive objects. This could be crucial for future missions to distant stars or even for maintaining communication with probes exploring the outer reaches of our solar system. Another intriguing possibility is the potential to use Saturn's gravitational field to simulate extreme conditions found near black holes or neutron stars. These cosmic objects are known to warp time and space to an extreme degree, but studying them directly is incredibly challenging. By using Saturn as a proxy, we could gain insights into how time behaves in these extreme environments, bringing us closer to solving some of the universe's greatest mysteries. Of course, the challenges of conducting such experiments are significant. The technology required to measure time dilation with the necessary precision would need to be incredibly advanced. Additionally, the logistics of sending equipment to Saturn and ensuring it functions in such a harsh environment would require careful planning and innovation. But as history has shown, the pursuit of knowledge often leads to unexpected breakthroughs and technological advancements. As we ponder the idea of Saturn as a cosmic time machine, it's clear that this gas giant holds more than just beauty. It's a gateway to understanding the very fabric of space and time. And with that, let's turn our attention to another captivating vision: the possibility of cultivating plants on Saturn's moons to create cosmic gardens. What would it take to grow food and produce oxygen in such an alien environment? Let's find out. Now, let's shift our focus to a vision that blends science, survival, and a touch of green, turning Saturn's moons into cosmic gardens. Imagine a future where humanity doesn't just explore these distant worlds but cultivates them, growing plants to produce food and oxygen in the harshest of environments. This idea might seem like a stretch, but with the right innovations, it could become a cornerstone of life beyond Earth. Saturn's moons, particularly Titan and Enceladus, present unique opportunities for space agriculture. Titan, with its thick atmosphere and organic-rich surface, offers a promising environment for growing plants. Enceladus, on the other hand, boasts vast reservoirs of water beneath its icy crust, a critical resource for sustaining life. However, transforming these moons into fertile grounds is no small feat. The challenges are immense, but so are the potential rewards. One of the biggest hurdles is the extreme cold. Temperatures on Saturn's moons can plummet to hundreds of degrees below freezing, making traditional farming impossible. To overcome this, we'd need advanced greenhouse technology capable of maintaining stable, Earth-like conditions. These structures would have to be incredibly robust, designed to withstand not only the cold but also the lack of sunlight and the potential for micrometeorite impacts. Artificial lighting powered by solar energy or nuclear generators would be essential to provide the energy needed for photosynthesis. Another challenge is the lack of soil. Saturn's moons don't have the nutrient-rich dirt we rely on for farming on Earth. Instead, we'd need to develop hydroponic or aeroponic systems where plants grow in water or air infused with nutrients. These systems would have to be highly efficient, recycling water and nutrients to minimize waste and ensure sustainability. Scientists are already experimenting with these methods on the International Space Station, laying the groundwork for larger-scale operations on distant moons. Then there's the question of oxygen. While plants naturally produce oxygen as a byproduct of photosynthesis, creating a breathable atmosphere on a moon like Titan would require vast amounts of vegetation. This means scaling up agricultural operations to an unprecedented level, potentially covering large swaths of the moon's surface with greenhouses. The oxygen produced could not only support human life but also be stored for use in spacecraft or other habitats. But why stop at survival? These cosmic gardens could also serve as a source of fresh food, reducing the need to transport supplies from Earth. Imagine astronauts harvesting tomatoes, lettuce, or even strawberries grown millions of miles from home. Beyond practicality, these gardens could provide psychological benefits, offering a connection to Earth and a sense of normalcy in an otherwise alien environment. Of course, the road to creating cosmic gardens is paved with challenges. The technology required is still in its infancy, and the logistics of transporting equipment and establishing infrastructure on Saturn's moons are daunting. Yet the potential benefits sustaining human life, advancing space agriculture, and deepening our understanding of extraterrestrial ecosystems make this vision worth pursuing. As we dream of greenhouses dotting the icy landscapes of Saturn's moons, let's turn our attention to another bold idea: using Saturn as a cosmic archive to preserve Earth's knowledge for future generations. What would it take to store humanity's collective wisdom on a distant planet, and why might Saturn be the perfect place for such a project? Let's explore. Now, let's venture into a future where Saturn becomes more than just a planet. It transforms into a cosmic library, safeguarding humanity's collective knowledge for generations to come. Imagine a scenario where Earth's most valuable information, from scientific discoveries to cultural heritage, is preserved on Saturn's moons, ensuring its survival even in the face of potential catastrophes on our home planet. This idea, while ambitious, raises fascinating questions about technology, ethics, and the legacy we leave behind. Saturn's moons, particularly Titan and Enceladus, offer unique advantages for such a project. Their remote locations and stable environments make them ideal candidates for long-term storage. Titan's thick atmosphere could shield stored data from cosmic radiation, while Enceladus's icy crust might provide a natural freezer for preserving physical artifacts. But how would we go about creating a cosmic archive in such distant and challenging environments? The first step would be developing advanced data storage systems capable of withstanding extreme conditions. Traditional hard drives and flash memory wouldn't survive the harsh temperatures and radiation of space. Instead, we'd need to explore cutting-edge technologies like quartz glass storage, which can encode data in tiny nanostructures that last for millions of years, or DNA-based storage, where information is stored in synthetic DNA molecules. These methods are still in their early stages, but they hold immense promise for creating durable, high-capacity archives. Transporting this technology to Saturn's moons would be another monumental challenge. We'd need spacecraft capable of carrying heavy payloads across vast distances, as well as robotic systems to construct and maintain the archive once it's in place. Autonomous robots powered by solar energy or nuclear generators could be deployed to build protective structures and ensure the archive remains operational over centuries. But beyond the technical hurdles, there are profound ethical considerations to address. Who decides what information is worth preserving? Should the archive include only scientific and historical data, or should it also capture the diversity of human culture, from art and literature to personal stories? And how do we ensure that future generations, or even extraterrestrial civilizations, can access and understand the information we leave behind? These questions highlight the responsibility we bear in shaping humanity's legacy. Another concern is the potential for misuse. A cosmic archive could become a target for exploitation or conflict, especially if it contains sensitive or proprietary information. Establishing international agreements and safeguards would be essential to protect the archive and ensure it serves as a resource for all of humanity, rather than a tool for power or control. Despite these challenges, the idea of a cosmic archive on Saturn's moons is a compelling one. It represents not just a technological achievement, but a profound statement about our desire to preserve and share knowledge across time and space. By safeguarding our collective wisdom, we could inspire future generations to continue exploring, learning, and dreaming. As we ponder the possibilities of Saturn as a cosmic archive, let's turn our attention to another bold vision, using Saturn's rings as a cosmic defense system. Could these iconic rings serve as a shield against asteroids or space debris? Let's explore this intriguing idea next. Now, shifting our gaze from the idea of Saturn as a cosmic archive, let's explore a concept that feels like it's straight out of science fiction: Saturn's rings as a cosmic defense system. Picture those iconic, shimmering rings, not just as a breathtaking celestial feature, but as a protective barrier against asteroids, comets, and space debris. Could Saturn's rings serve as a natural shield for our solar system? Let's dive into the possibilities. Saturn's rings are composed of countless particles, ranging from tiny grains of dust to massive chunks of ice and rock. This dense, layered structure could theoretically act as a buffer, absorbing or deflecting incoming objects that might otherwise pose a threat to planets like Earth. The idea is to harness the ring's natural composition and position to create a passive defense mechanism, reducing the risk of catastrophic collisions. But how feasible is this concept? To begin with, Saturn's rings are already doing some of this work naturally. The planet's gravitational pull attracts nearby debris, and the rings act as a sort of cosmic filter, capturing smaller objects before they can travel deeper into the solar system. However, scaling this up to protect against larger threats like kilometer-wide asteroids would require significant advancements in technology and engineering. One approach could involve enhancing the ring's density or structure by introducing additional material, perhaps mined from Saturn's moons or transported from elsewhere. We could create thicker, more robust layers capable of withstanding larger impact. Alternatively, we might deploy advanced monitoring systems to track incoming objects and strategically position reinforced sections of the rings to intercept them. Another intriguing possibility is the use of directed energy or kinetic impactors to break apart larger asteroids before they reach the rings. This would involve a combination of ground-based and space-based technologies, working in tandem to neutralize threats before they become unmanageable. While this sounds like a monumental task, it's not entirely beyond the realm of possibility, given the rapid advancements in space technology. Of course, there are challenges to consider. Saturn's rings are delicate structures, and any large-scale intervention could disrupt their natural balance. We'd need to carefully study the ring's composition and dynamics to ensure that our efforts don't inadvertently cause more harm than good. Additionally, the sheer scale of such a project would require unprecedented international collaboration and resources. Beyond the technical aspects, there are also ethical and philosophical questions to ponder. Should we intervene in natural processes to protect ourselves, or would doing so set a precedent for altering celestial bodies in ways we can't fully predict? And if we succeed in creating a cosmic defense system, how do we ensure it's used responsibly without escalating tensions or conflicts over control? Despite these complexities, the idea of Saturn's rings as a cosmic defense system is undeniably captivating. It represents a bold vision of humanity's ability to adapt and innovate, using the resources of our solar system to safeguard our future. Whether or not this becomes a reality, it sparks the imagination and reminds us of the endless possibilities that await as we continue to explore the cosmos. With this vision of Saturn's rings as a protective shield in mind, let's turn our attention to another fascinating possibility: Saturn as a cosmic artifact. Could this majestic planet hold clues to ancient alien civilizations? Let's uncover the mysteries next. Now, as we venture further into the realm of possibilities, let's explore a concept that feels like it's been plucked straight from the pages of an interstellar mystery novel: Saturn as a cosmic artifact. Could this majestic planet, with its swirling storms and iconic rings, hold secrets to ancient alien civilizations? The idea might sound like science fiction, but when we consider the vastness of the universe and the potential for life beyond Earth, it's a question worth asking. Saturn's moons, in particular, are a treasure trove of intrigue. Take Titan, for example, with its thick atmosphere and liquid methane lakes, or Enceladus with its icy surface and subsurface ocean. These moons are not just barren rocks, they're dynamic worlds that could have hosted, or might still host, conditions suitable for life. But what if they also hold evidence of civilizations that existed long before humanity? Imagine discovering ancient structures, tools, or even remnants of technology buried beneath the ice or hidden in the shadows of Saturn's rings. One possibility is that Saturn's moons could have served as outposts or waypoints for advanced alien species. If a civilization had the capability to traverse the stars, it's not far-fetched to think they might have used Saturn's system as a base of operations. The planet's gravitational pull and its rings could have provided natural protection or resources for such a civilization. Over time, as these beings moved on or disappeared, their artifacts might have been left behind, waiting to be discovered. Another angle to consider is the potential for natural phenomena to mimic artificial structures. For instance, certain geological formations on Saturn's moons could resemble buildings or machinery, sparking debates about their origins. While these might turn out to be purely natural, they could still offer valuable insights into the processes that shape these distant worlds. On the other hand, if we were to find something truly inexplicable, like a perfectly symmetrical structure or an object made of materials not native to the Moon, it could revolutionize our understanding of the universe. Of course, the search for such artifacts would require advanced technology and meticulous exploration. Robotic probes equipped with high-resolution cameras, ground-penetrating radar, and sophisticated sensors would be essential for scouring the surfaces and interiors of Saturn's moons. Even then, the sheer scale of these moons and the harsh conditions they present would make the task incredibly challenging. But if history has taught us anything, it's that humanity thrives on challenges, especially when the rewards could be so profound. Beyond the scientific implications, the discovery of alien artifacts on Saturn's moons would have a profound cultural and philosophical impact. It would force us to confront questions about our place in the universe, the nature of intelligence, and the possibility of civilizations far older and more advanced than our own. It could also inspire a new era of exploration as we seek to uncover the stories of those who might have come before us. As we ponder the idea of Saturn as a cosmic artifact, it's impossible not to feel a sense of wonder and curiosity. Whether or not we ever find evidence of ancient alien civilizations, the mere possibility reminds us of the boundless mysteries that await us in the cosmos. And with that thought in mind, let's turn our attention to the final chapter of our journey, Saturn as a cosmic beacon, guiding humanity's exploration of the stars. Now, as we shift our gaze to the final frontier of our journey, let's consider Saturn not just as a planet of mystery, but as a guiding light in the vast expanse of space. Imagine Saturn as a cosmic beacon, a celestial lighthouse that could help humanity navigate the uncharted waters of interstellar travel. With its unmistakable rings and prominent position in our solar system, Saturn could serve as a natural landmark for spacecraft venturing beyond our cosmic neighborhood. One of Saturn's most striking features is its rings, which are visible from great distances and could act as a universal signpost. For spacecraft traveling through the darkness of space, these rings would provide a clear and unmistakable reference point, helping to orient their trajectory. Think of it like using a lighthouse to guide ships through foggy seas. Saturn's rings could offer a similar function, ensuring that explorers stay on course as they journey deeper into the galaxy. But Saturn's usefulness as a navigational marker doesn't stop at its rings. The planet's gravitational pull could also play a crucial role in interstellar travel. By using Saturn's gravity as a slingshot, spacecraft could gain the speed needed to reach distant star systems more efficiently. This technique, known as a gravity assist, has already been used in missions like Voyager and Cassini, but on a much larger scale, Saturn's gravity could propel ships toward destinations that are currently beyond our reach. Another advantage of using Saturn as a cosmic beacon is its relative stability. Unlike stars, which can vary in brightness or position, Saturn's position in the solar system is predictable and consistent. This reliability makes it an ideal reference point for long-term missions, where even the smallest navigational errors could lead to significant deviations over vast distances. By aligning their paths with Saturn, spacecraft could ensure greater accuracy and reduce the risk of getting lost in the void. Of course, the idea of using Saturn as a navigational tool raises intriguing questions about the future of space exploration. Could we one day build infrastructure around Saturn to support interstellar missions? Imagine space stations orbiting the planet, serving as waypoints for travelers and providing resources for ships passing through. These stations could also house advanced telescopes, allowing us to study distant galaxies while using Saturn as a stable base of operations. Beyond its practical applications, Saturn's role as a cosmic beacon carries a symbolic weight. It represents humanity's ambition to explore the unknown and our desire to leave a lasting mark on the universe. Just as ancient mariners used the stars to guide their journeys, future explorers might look to Saturn as a symbol of hope and direction in the vastness of space. As we conclude our exploration of Saturn's potential, it's clear that this magnificent planet holds more than just scientific intrigue. It embodies the spirit of discovery that drives us forward. Whether as a navigational aid, a source of inspiration, or a stepping stone to the stars, Saturn's legacy as a cosmic beacon reminds us that the universe is full of possibilities waiting to be explored. And with that thought, we turn to the final reflections on Saturn's enduring role in shaping humanity's future among the stars. Now, let's take a closer look at how Saturn could become a central hub for galactic exploration, opening doors to the farthest reaches of our solar system and beyond. Picture Saturn not just as a planet, but as a bustling cosmic outpost, a place where humanity's journey into the stars truly begins. With its unique position and resources, Saturn has the potential to serve as a launch pad for missions that push the boundaries of what we thought was possible. To make this vision a reality, we'd need to build advanced infrastructure around Saturn. Imagine massive space stations orbiting the planet, equipped with state-of-the-art technology to support long-term missions. These stations could serve as refueling hubs, repair centers, and even research facilities, allowing spacecraft to prepare for the long journey ahead. With Saturn's abundant hydrogen reserves, these stations could produce fuel on site, reducing the need to transport resources from Earth and making interstellar travel more sustainable. But the potential doesn't stop there. Saturn's moons, particularly Titan and Enceladus, could play a crucial role in this galactic exploration network. Titan, with its thick atmosphere and liquid methane lakes, could serve as a base for studying extreme environments and testing technologies for other icy worlds. Enceladus, with its subsurface ocean, offers the tantalizing possibility of discovering extraterrestrial life, making it a prime target for scientific missions. By establishing bases on these moons, we could unlock new insights into the origins of life and the potential for habitability beyond Earth. Saturn's gravitational influence could also be harnessed to propel spacecraft toward distant destinations. By using the planet's gravity as a slingshot, missions could achieve the speeds needed to reach the outer edges of the solar system and even neighboring star systems. This technique, combined with advancements in propulsion technology, could drastically reduce travel times, making interstellar exploration more feasible than ever before. Beyond its practical applications, Saturn's role as a hub for galactic exploration carries profound implications for humanity's future. It represents a stepping stone, a place where we transition from being Earth-bound explorers to becoming a truly spacefaring species. The discoveries made at Saturn could reshape our understanding of the universe and our place within it, inspiring generations to dream bigger and reach further. As we look to the stars, Saturn stands as a symbol of what's possible when we combine curiosity, innovation, and ambition. It's not just a planet, it's a gateway, a place where the next chapter of human exploration begins. And with each mission launched from its orbit, we take one step closer to unlocking the mysteries of the cosmos. Now, let's shift our gaze from the scientific and practical aspects of Saturn to something equally fascinating, its cultural significance. Saturn has long captured the imagination of humanity, not just as a celestial body, but as a symbol of wonder and mystery. Its iconic rings and majestic presence have made it a staple in science fiction, literature, and art, shaping how we envision the future of space exploration and our place in the cosmos. Think about the countless stories, movies, and artworks that have depicted Saturn as a backdrop for epic adventures, or as a destination for humanity's greatest achievements. From classic science fiction novels to blockbuster films, Saturn often represents the unknown, the frontier waiting to be explored. This cultural portrayal has a profound psychological impact, fueling our collective curiosity and inspiring generations to look beyond Earth. It's not just a planet, it's a canvas for our dreams and aspirations, But Saturn's cultural influence goes beyond mere inspiration. It also shapes how we perceive our role in the universe. When we see Saturn depicted as a place of discovery and possibility, it reinforces the idea that humanity is destined to explore and expand its horizons. This narrative can have a powerful societal effect, encouraging investment in space exploration and fostering a sense of unity as we work toward common goals. Saturn becomes more than a planet, it becomes a shared vision of what humanity can achieve when we dare to dream big. At the same time, Saturn's prominence in popular culture raises important questions about our relationship with the cosmos. How do these depictions influence our expectations of space exploration? Do they create unrealistic ideals, or do they motivate us to push the boundaries of what's possible? These are questions worth exploring as we consider the psychological and societal implications of Saturn's cultural legacy. Ultimately, Saturn's role in our collective imagination serves as a reminder of the power of storytelling. It shows us that the stories we tell about the universe can shape our ambitions, our values, and even our future. As we continue to explore Saturn and its moons, we're not just uncovering scientific truths, we're also writing the next chapter in humanity's cosmic narrative. And with each new discovery, we add another layer to the rich tapestry of Saturn's cultural significance, ensuring that it remains a beacon of inspiration for generations to come. As we bring our journey through these predictions to a close, it's impossible not to reflect on Saturn's enduring legacy. This magnificent planet, with its breathtaking rings and mysterious moons, has captivated humanity for centuries. But its significance goes far beyond its physical beauty. Saturn represents something deeper, a symbol of curiosity, ambition, and the boundless potential of human imagination. It's a reminder that the universe is not just a place to explore, but a source of endless inspiration. For future generations of explorers, Saturn stands as a beacon of possibility. Its rings and moons hold secrets waiting to be uncovered, challenges waiting to be overcome, and opportunities waiting to be seized. Every mission to Saturn, every discovery made, adds to the growing tapestry of knowledge that will guide the next wave of adventurers. Whether it's through scientific breakthroughs, technological innovations, or the sheer thrill of exploration, Saturn will continue to push humanity to reach for the stars. For scientists, Saturn is a living laboratory offering insights into the origins of our solar system, the potential for extraterrestrial life, and the dynamics of planetary systems. Its complex atmosphere, its icy moons, and its iconic rings provide endless avenues for research and discovery. Each new finding not only deepens our understanding of Saturn, but also reshapes our understanding of the cosmos itself. In this way, Saturn becomes more than a planet. It becomes a teacher, challenging us to ask bigger questions and seek greater truths. And for dreamers, Saturn is a canvas for the imagination. Its presence in art, literature, and popular culture reminds us that the universe is not just a place of science, but also a realm of wonder. It invites us to dream of futures where humanity thrives among the stars, where the impossible becomes possible, and where the mysteries of the cosmos are unraveled one by one. Saturn's legacy is not just about what we discover, but about what we dare to imagine. As we look to the future, Saturn's role in shaping humanity's destiny is undeniable. It inspires us to think beyond our limits, to embrace the unknown, and to strive for greatness. Whether through the eyes of an explorer, the mind of a scientist, or the heart of a dreamer, Saturn will always be a symbol of what humanity can achieve when we dare to look beyond the horizon. And as we continue to explore its mysteries, we ensure that its legacy will endure, inspiring generations to come to reach for the stars and beyond. As we wrap up this exploration of Saturn's future, it's clear that the possibilities are as vast as the planet itself. From harnessing its hydrogen reserves for clean energy to transforming its moons into thriving colonies, each prediction we've discussed blends cutting-edge science with the limitless power of imagination. Saturn isn't just a planet, it's a symbol of what humanity can achieve when we dare to dream big and push the boundaries of what's possible. Whether it's through technological innovation, scientific discovery, or the sheer thrill of exploration, Saturn offers a glimpse into a future where the stars are within our reach. These 25 predictions remind us that the universe is full of opportunities waiting to be seized. They challenge us to think beyond our current limitations and envision a world where humanity thrives not just on Earth but among the planets and moons of our solar system. Saturn's rings, its storms, and its moons are more than just celestial wonders. They're invitations to explore, to innovate, and to imagine. Now we want to hear from you. What do you think about these predictions? Which ones excite you the most? And what ideas do you have for Saturn's future? Share your thoughts in the comments below. We'd love to hear your vision for what lies ahead. And if you enjoyed this journey through the possibilities of Saturn, don't forget to hit that subscribe button and ring the notification bell. There's so much more futuristic content coming your way, and we can't wait to explore the next frontier with you. Thanks for watching, and remember, the future is out there waiting to be discovered. Let's reach for it together.